Okay, we will go through some important points in the class 12 physics chapter 9 ray optics and optical instruments. Okay, this is the visible light spectrum, region of the spectrum. Light travels in a straight line. This is the velocity of light in vacuum. Okay, this is important. This is medium is vacuum. Path of the light, a ray of light. Okay, path is called ray of light. So if you take a surface like this is the normal to the surface. Okay, this is normal. This is the incident angle and the reflected angle. These are the sign conventions. Okay, the object is on the left side of the lens. Okay, this height above is positive, height below is negative. Distance towards left is negative, the right is positive. Cartesian sign conventions. Focal length. There are two type of mirrors, concave and convex, and this is the principal axis. Okay, this is principal axis. This is center of curvature C. This is the focal focus or focal length, pole P. Okay, see, this is for the concave, that is the diverge at focus, rays diverge at the focus. These points C and F is other side here, this side for the convex. So this is a diverge at F. This is converge at F and diverge at F. Position of this C where is here? C and F here. This is the focal plane around the focus. Distance between the focus and the pole is the focal length. Okay, this is the pole and this is the focus. Between this is the focal length. F and P, focal length. Okay, this is the focal length. Mirror equation. This is the object and this is the image. Okay, and these are the image formation rules. What is the real image and the virtual image? The image is real if the rays actually converge. The virtual if the rays do not actually meet. Okay, so this is a real image because the rays meet here. These are the image formation rules. This is the mirror formula, mirror equation. U is the object distance, V is image distance, this is the focal length. Magnification, height of the image divided by the height of the object. So this is one scenario where object is between the focus and the pole. Okay, focus and the pole, the object is here. This is the image. So this is the virtual image because it is not the real interception, it is just the extended. So this is the virtual image. Suppose that the lower half of the concave mirror reflecting surface is covered with a opaque material. What effect will this image of the object? So the area of the reflecting surface has been reduced. The intensity of image will be low. Okay, only intensity will be low. So in this case, the half of the intensity. Okay, image will be there, but the intensity will be low. Yeah, mobile phone lies along the principal axis of the concave mirror. Okay, show by the suitable diagram the formation of the image. Or explain why the magnification is not uniform. Okay, because this reflected ray is bending. Object is placed at 10 centimeters in front of the concave mirror of radius curvature. Okay, find the position nature. Focal length equal to radius of curvature by 2. In front of the object is placed at 10 cm in front of the concave mirror. In front means that is it comes on the left side, so it will be negative sign. So they are using sign convention, the negative sign. E is negative. Okay, the object is in front of the mirror, left side. So the sign of V image is computed based on this. So we are not assigning, that is computer result. So it is negative. So image is formed on the opposite side of the mirror. Same side of the object, because object is also left side, the V is negative, so that is also on the left side. Magnification, that means it is inverted. That is the inverted, because magnification is negative. Real, because it based on the ray incident. So here the magnification positive. So that is the erect. Suppose while sitting on a parked car, you notice a jogger approaching towards you. In the side view of the mirror R is given. The jogger is running at the 5 meters per second. How fast the image of the jogger appear to move? The jogger is at this distance. Okay. So we are computing the image at various object distance. So object is here, the image will be at this distance. So similarly for the other things. So based on that they conclude, although jogger has been moving at this constant speed, the speed of his her image appears to be increased substantially as he moves closer to the mirror. That is the non-uniform acceleration. Okay, this phenomena can be noticed by any person sitting in the stationary car. In case of the moving vehicles, similar phenomena. Okay, refraction obliquely means this angle is between 0 and 90 degree. Incident angle, this is the reflected, and this is the angle of refraction here R for the positive refractive index. Okay, medium to medium, rarer to denser medium. Moves towards the normal. Okay, Snell's law, sine of incident angle by sine of refracted angle. Optical density versus mass density. This is when you are going from 1 to 2, then again from 2 to 1. Air to glass, glass to air. Air to glass. Moving towards the normal. Glass to air, away from the normal. Okay. This is the apparent depth, real depth when you see from this position and this position. So apparent depth is real depth divided by the refractive index. Total internal reflection. This will happen when the angle of incidence is greater than the critical angle. This happens from denser to rarer medium only. Total internal reflection denser to the rarer medium. So here the angle of incidence should be greater than the critical angle. So there are two conditions: denser to rarer and the angle of incidence greater than the critical angle. Then total internal reflection takes place. In this case, the critical angle and refractive index of medium 1 with respect to 2, medium 1 1 is here, here 2 is here. Okay, medium 1 is the denser medium. Air is the rarer medium. Medium 2 is air, medium 1 is denser medium. So medium 1, denser medium. Refractive index of 1 with respect to 2 is 1 by sine of critical angle. These are some applications of the total internal reflection. Okay, bend rays, image inversion. Towards normal, rarer to denser medium, towards normal, refraction towards normal. Okay. So here you have to take the refractive index of the air as 1. So here plus, actually there is a minus in the formula and there is one more minus. So this is negative and this is based on the Lenz's formula. 1 by V minus 1 by U equal to 1 by F. So actually this 1 by F n12 minus 1, this 1 here and here is actually is n1, refractive index of air, n1 equal to 1. n1 is here. This is Lenzmaker's formula, this formula. R1, R2 are the radius of curvature of the lens 1 and 2. So even if you interchange the object position other side, then the focal length won't change as per this formula. Image formation rules for the convex lens. Okay. Object at 2f. So image is here. This is inverted image. A magician during a show makes a glass lens with a refractive index disappear drop of liquid. So this liquid refractive index same as this. Power of the lens. Power equal to 1 by f, power of the lens. The unit of power is diopter. See, this is the important here, how to use the refractive index from the lens maker's formula. See, here we are using 1 by f n minus 1 this, but here you see we are using the refractive index of the water. So you have to be careful in using that formula here, refractive index. Lens maker formula. For water, refractive index 1 for air is changed for the water 1.33. Combining lenses. Focal length of the combined lens. Power of the combined lens. Magnification of the combined lenses. So here the important thing, if you keep like this, the object for this length will be image from this lens. So object for this length will be image from this lens. Okay. For the first lens, this is the image distance. This acts as the object for the second lens. Image formed by the first lens serves as the object for the second lens. Okay. So here important thing, when focal length is negative, that means it's a diverge. So the image is opposite side of this. Okay. This object acts as an object for the third lens. Refraction through prism. The important thing here is the velocity of light will differ in this medium, in the prism. In the air it is constant, but it depends in the prism, it depends on the color, wavelength of the color. R1 plus R2 equal to A. This angle and this angle is equal to this angle. Angle of deviation depends on the angle of incident. Angle of incidence versus angle of deviation. This is the curve. You see, for some of the values, there are two values of angle of incident. That is important. Okay. For some of these deviation, there are two angle of incidence. This is the formula. Optical instruments. Important thing is microscope and telescope. Is the both are magnifiers, but the lens arrangement will be different. For the microscope, the areas get erect, magnified, and virtual images. Erect, magnified, and virtual images. This is the subtended angle from the eye. This is how this is angle subtended. Distance, near point. This is the magnification 1 plus d by f. So magnification will be more when focal length is less. This is the angular magnification. The 1 is removed. Okay, 1 plus d phi f becomes d by f, angular magnification. So here the thing is that the difference in the focal length, eyepiece focal length more than the objective and eyepiece. This focal length is more than this objective and eyepiece. Magnification. But for the telescope, objective, here this ulta, objective focal length is more than the eyepiece focal length here for the telescope. Microscope, FE, that is eyepiece focal length is more than the objective focal length, but here this is ulta. This produces inverted image. See here, this is less than this for the telescope. Okay, you can go through the summary also. Points to ponder.